Okay, so let's start with vertex form, which reminder, vertex form from yesterday is y equals a times the quantity x minus h squared plus k. And remember, we also sometimes call it transformational form because the transformations are there. A, h, and k tell us how to move our quadratic. All right, so this is my one example for a vertex form, but you already know how to do all of this from yesterday. So the problem, if you want to just jot down the function, f of x equals negative 2 times the quantity x plus 3 squared. Whenever I say the quantity, that means in parentheses, and plus 4. And then you probably don't have to write down all the directions, but in your notebooks, go through the example. So please do the following. Graph it. Identify your vertex and axis of symmetry. Decide if you have a minimum or a maximum value. Figure out your domain and range. And also do the increasing and decreasing intervals. Remember to be specific and write your answers as inequalities. So go ahead and see what you can do, and you can talk to your group members if you want. As I walk around the room, it's interesting to see people do it different ways. Some people are filling out all the information without the graph. Then they're going to graph. Some people are graphing first, and then you can use your graph to answer those questions. So good ways to do it both. It's always in relation to x. So you're talking about left and right on the graph. Where is it increasing or decreasing? You can just write it as an ordered pair, like it is the vertex. And then sometimes the big question might ask, like on that was the arm, or the problem, is that what's the max height of the object? Then you would be answering only the y coordinate, but it might also ask how many times it reaches max height. So that you can write max and ordered pair for maximum. Yeah. Oh, see, I think on your quiz you just had a flip-flop. I think maybe. And then I was like, no. Yep. Joy's redemption. Okay. So one question that you've been practicing in the chapter 1 stuff is stating all the transformations. So if you look at that, there's 4 transformations. Can we list them out? Reflection in the x-axis. What else happens? Left 3. Up 4. What's that 2 doing out front? Vertical stretch of 2. Okay, so I can put all those things together. I'm going to go left 3 and up 4. There's my vertex. Instead of, like on the parent graph, I would normally go up 1, right 1, up 1, left 1. Because of the 2 transformations, the reflection and the vertical stretch, instead of going up, I'm going to go down. And instead of going down 1, I'm going to go down 2 because I'm vertically stretching it. So I could go down 2, right 1, and down 2, left 1. And I'd say this, like on your quizzes and tests, when you show me a graph, have at least 3 points. So, you know, some people would take the shortcut of like plot the vertex, draw a shape. Give me a couple extra points for a semi-accurate graph as opposed to just a quick sketch. Okay. So this is enough to draw. Pretend it went through the point. And remember that if you want to get some extra points, you can, but be really careful. You're not going to keep going down 2 because it doesn't have constant slope like the absolute value. The next step in a parent graph after you go up 1, right 1 is to go up 4, right 2. So if you wanted some extra points, then you would be going, instead of going up, you'd be going down. And instead of 4, it would be 8 if you multiply it by 2. So just be thoughtful about that. If you're going to add extra points, they need to be accurate. Okay, so now I can label my vertex. As I'm walking around, I see really good work, -3, 4. You can get that from your transformations on your graph. You can get that from the equation. Pull out h and k. Your axis of symmetry is x equals -3. The axis of symmetry is always through the vertex, so it's always x equals the x coordinate of the vertex. Does this graph have a min or a max? Max at the vertex -3, 4. So 4 is the maximum y value, and we'll use that in our range. What's our domain? X equals all real numbers. So I sure hope everybody gets those points on all their quizzes and tests. Range, y's that are less than. So less than or equal to 4. Okay, because it actually goes up to 4. So we're talking about y's. The highest y is 4. That's the maximum y value. And then it's everything less than 4, but it also includes 4. For increasing and decreasing, the key to remember with increasing and decreasing is you're talking about left and right. So you're talking about x's. What are you doing on the left side of the axis of symmetry? Increasing. So for all x's that are less than -3. Remember that for increasing and decreasing, it's going to be like x is less than h, x is greater than h. It's going to be split by the axis of symmetry, which is x equals h. And then once you get to the vertex, you turn around, so then you start decreasing. That's on the right side, so that's all x is greater than -3. Now, notice again on those increasing and decreasing, I don't put or equals to, because at -3, it's turning around. So I don't say increasing. You guys did a really nice job. Give yourself a little pat on the back. Okay, now we're going to do all those same things with standard form, but it's going to be a little bit different, of course. So this should look familiar to you, standard form. F of x equals ax squared plus bx plus c. Besides x and y and a square, which all quadratics have, what's the only thing this has in common with vertex form? The a. So a still does the same thing. Positive a means my parabola opens up.
Negative A means my parabola opens down. If A, the absolute value of A is greater than 1, it's a vertical stretch. If the absolute value of A is less than 1 but greater than 0, it's a vertical shrink. So all the things that A used to do remain the same. You don't have to relearn A. But sadly, what is missing? H and K. And man, did I love H and K. Because H and K told me for my parent graph, when my vertex was at 0, 0, it just told me where to slide my vertex. And B and C are not the vertex. Because if they were, I would just write H and K right there. So nowhere in this equation do I see H and K. That face. So I'm left wondering, what is the vertex? So we have a method to find the vertex for standard form. Does anybody recall from Algebra 1 how you start finding the vertex in standard form? It's a tough one sometimes. Okay, I'm going to write it as an ordered pair first, and then I'll expand or explain a little bit. So I'm going to do an ordered pair, like normally I would write HK if it was vertex form. But we've got ax squared plus bx plus c, and the x-coordinate of your vertex is the opposite of b divided by 2a. So some people read that as negative b over 2a. That's fine. I call it the opposite of b, just so that if b is negative, you make it positive. Okay, so it's not that the top is always negative, it's the opposite. All right, so you're going to have to do a little bit of math work. Now, you'll find it's not as painful as it looks right there. You just do opposite b over 2a, and it'll reduce. It'll be some number, like it'll equal 3 or it'll equal 5. So if you know the x-coordinate of your vertex, let's say it was 3 or 5, how would you find the y-coordinate of your vertex? You knew the x. How do you find the y? Grace says. Is that you? Kristen? Who was it? Mickey?
Plug it in.
Plug it in. Okay. Plug it in. So I'm going to write in here f of negative b over 2a. Now, don't get too freaked out. It's just y when x is opposite of b over 2a. Right? That's a mathematician's definition function notation. So it's just saying plug it in. Now, some of us maybe need to write this down in terms we'll remember and understand later. So if you feel like that may be the case for you, let's do that. For the vertex, step 1. I'm actually going to say h equals the opposite of b over 2a. This is the x-coordinate of the vertex. Are you okay with me calling it h? Because it's like the h in vertex form? Okay. You could also say x equals. It's the x, but it's a special x. It's the x for the vertex. Okay. So step 1, do opposite of b over 2a. Step 2. Plug h, which is the opposite of b over 2a, in for x to find y. This is the y coordinate of the vertex. H is whatever you get for opposite of b over 2a. But you won't have to keep doing opposite of b over 2a once you find it. It'll just be a number. How many people feel like, I've maybe done that before in Algebra 1? Yeah, I mean, you study quadratics at the end, so it should be semi-familiar to us. Okay, we'll look at some examples. Okay, what would the axis of symmetry be then? Yeah, it's x equals h, which h is opposite of b over 2a. So let's say that the axis of symmetry is x equals the opposite of b over 2a. But remember, if you did the work for opposite of b over 2a previously, you don't have to redo the work. You just write the number there. And then, y-intercept. How do you find the y-intercept of a function in general? Okay, if you were graphing it, where would the y-intercept be? Where the line crosses the y-axis. So what's special about all the points on the y-axis? Every single point on the y-axis has something in common. No, it could be a 0, 1.5. Or it could be a 0, 3. Or it could be a 0, 0. Or it could be a 0, negative 20. What do they all have in common? X is equal to 0, so you don't move right or left, you stay on the y-axis. Okay, so in order to find a y-intercept for any function, you could plug 0 in for x. If you plug 0 into the standard form, what happens to the ax squared and the bx terms? They equal 0, so the y-intercept is c. Okay, so this is going to be a quick and easy third point or second point for us. The y-intercept in standard form is 0, c. And this will be really helpful because if we use our axis of symmetry, we can reflect the y-intercept over the axis of symmetry, and then we can draw the parabola. If for some reason you can't, like let's say your vertex is at the y-intercept, so it's reflecting over the y-axis, then you could just pick any point or any x value besides 0, plug it in and get an extra point, and then reflect it. Okay, but remember, you want to have like a few extra points. Or you could use your a value to vertically stretch or shrink, whatever is true. Okay, let's look at an example. Let's put this to work. We're going to do all those same things. It looks like a lot. I'd probably just write down the function. F of x equals 3x squared minus 6x minus 1. I mean plus 1. Okay, so we're going to go through all that work, find the vertex, find the axis of symmetry, max, min, domain range, increasing, decreasing. But we really want to focus on the front work because that's something we haven't done before together. Okay, so in transformational form or vertex form, I could have just stated all the transformations and then moved my vertex wherever it was and started my parabola there. Now I'm going to have to do work to find my vertex first. So what's the first step in finding my vertex? Opposite of b over 2a. Okay. So looking at this, ax squared plus bx plus c, a is 3, b is negative 6, and c is 1. When I do my vertex work, I'm going to say h equals the opposite of b, which would be positive 6, divided by 2 times a, which is 2 times 3. So 6 divided by 6 is 1. Okay. So I've got the x coordinate on my vertex. Now I want the y coordinate on my vertex. Okay, so to get the y coordinate on my vertex, I just have to take 1 and plug it in for all these x's. So that would be 3 times 1 squared minus 6 times 1 plus 1. Now, be very careful when you're doing a quadratic. You must follow the order of operations, and exponents come before multiplication. So 1 squared is 1. 3 times 1 is 3. Minus 6 plus 1. 3 minus 6 is negative 3 plus 1 is negative 2. I'm going to get a lot of people who do 3 times 1 is 3, square it to get 9. So beware, that's violating some gods. Okay, good news. Now I have my vertex, so I can plot that point, 1, negative 2. Since my vertex is not on the y-axis, I could easily find my y-intercept here. what's my y-intercept? One. If I were to plug 0 in for x, these things would cancel to 0, and I would just be left with 1. So my y-intercept is at 0, 1. And what I like about easily plotting my y-intercept, if I think about my axis of symmetry right here that passes through my vertex, so I could list my axis of symmetry. Axis of symmetry is x equals 1. Then I can just take my y-intercept and reflect it. So on the other side, it's going to show up at 2, 1. So it's 1 away from the axis of symmetry, but it's up 1. So it's 1 away from the axis of symmetry. If I didn't want to use the y-intercept, I could have used my a value as 3. That's a vertical stretch of 3. And it's positive, so the graph was going up. So it could have gone from the or from the vertex. Could have gone up 3, left 1. Up 3, right 1. I'm landing on the same point, right? Okay, now can we answer all the other questions? Yes. Does that have a min or a max? A minimum. Where is the minimum at? Then I'm going to say 1, -2 is the minimum point, but the minimum y value is -2, which is important when we do our range because that's the lowest y will ever be. What's our domain? X equals all real numbers. What's our range? Y is that are greater than or equal to -2. So remember what TJ said. -2 was the minimum value. Okay? And then increasing and decreasing. I like to think about okay, what's happening on the left? So when x is less than 1, my axis of symmetry, what's the graph doing? Decreasing. So x is less than 1, and then at x is greater than 1, it is increasing. Okay, so those things flip-flop if you have min or max, the less than or the greater than. All right, did I miss anything? Did I confuse anyone? What's happening? Okay. All right. So I'm going to hand back your quizzes. I'm going to talk about them here in just a moment. But while I'm handing them back, if you could just find the vertex, just so we can practice that opposite of b over 2a and plugging in, could you calculate the vertex while I am passing back your quizzes? And then after that, we can get started on our homework.